Howdy, y'all. So, in the last few videos, we've been talking about fragment shaders, and we're 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 using now. I was sort of showing you how to set these uniform values dynamically using REGL. So we're getting this time value now that's incrementing, and we can use that. We can do all kinds of function assignments in here to generate dynamic patterns, and we'll get to that in a minute. And I'm going to return to that. Um, and of course, we can also do that with the vertex shader. Um, there's so much we can do. We've written so little here, really, to create this interesting pattern, and it's interesting. I think it's a neat way to show um, that one value, that sign function, is being rendered differently for every pixel on this screen. And so working with these shaders is kind of this conceptual leap, right? Because this program that we're writing here is running um, many times at the same time. And I would just, you know, ask you to remember that video where the guy made a pink gun, and our Canvas 2D methods, or our old-fashioned drawing methods, right? We're drawing a circle dot by dot. This is drawing the circle every pixel simultaneously. So this function is running all at once on the GPU. And it's really pretty neat, but it's a little hard to wrap your brain around. And so this time I want to, or right now what I want to do is just sort of show a little bit of that before we move into integrating this noise function. And we'll do that by drawing a circle. And you can see I brought in a function here called circle, which I brought in from the book of shaders. And this is actually, it's a really fast, but it's kind of a complex function. Um, but I just wanted to show you how we can bring in a function if you're in the book of shaders and learning how you can incorporate their code, right? And so here in this example from uh, the segment on shapes, um, you can see it's written a little bit differently than we've been writing. There's this if def end if here, which is for GLES, but since we're using a slightly different syntax, we just write this here, precision medium p float. Has the same effect. And then there's the uniforms, and those look a lot like ours, right? Here's a function, and here's void main. Very often, instead of this GL frag chord value, we're going to have something like our varying. But we can talk more about that in other videos. Now this function, the circle function, is going to return a float value, and it's going to have two inputs. One input, which is going to be a type of vec2, so that's our varying, right, which is a type of vec2, and one which is going to be a float, which is going to be the radius of this circle. So we're going to draw a circle by calculating for each pixel whether it is inside or outside of the distance from the center of our calculations to a radius value. And so what I'm going to do is just remove this sine function we were using and use the circle function. And we'll pass in that UV value, and we'll pass in a radius. And let's see what we get. We get a circle, yes. Now that circle is up and to the right. And that's because the coordinate spacing here is a little bit off. So we're gonna fix that. And I'm actually also gonna show you another implementation of this. This is nice, and it's fast, but it's got some stuff going on that I really don't want to have to talk about right now. So instead of this, what I'm gonna do is I'm gonna make a We're just going to make a one-liner, sort of a one-line uh, variable here, and we'll say float in circle. And so now that's going to be, I'm making a float value, and I'm going to pass that in here as our mix. And so remember, this mix value is taking uColor1 or uColor2 based on how, for each pixel, based on whether that's 0 or 1 or where in between 0 and 1 it is, right? And so this value in circle, what we're going to do is we're going to return either a 0 or a 1 using a function called step. And step just basically returns true or false, which is 0 or 1, depending on two values, right? And so, and we can look that up even. We can say OpenGL step. It's no good. Step. There we go. I figured out even though I misspelled it. Step. Generate a step function by comparing two values. So we'll have an edge, and we'll have a value to be used to generate the step function. And I think it's probably easiest just to see this in action, right? And so step is we're given the radius. And you see up here in the circle function, they're also using smooth step, which is similar to step, but it just generates a kind of a gradient between two areas. So there's room for truthy and falsy and sort of mixy values to come out of it. So step, we're gonna pass in as our test. We're just gonna pass in a distance value, which is gonna be the length from this pixel to UV. And if that length is less than 0.5, it's gonna return true. And let's see what happens here. Open that up, and we get a circle. Nice. And we could obviously invert those colors. The easiest way to do that would be to just switch these colors here. And yeah, so the other thing I wanted to show you here before we move on to noise is a thing called fract, which is another really super useful function. So we just looked at step, which is used a lot in these shaping functions, and another one to create kind of tiled patterns is called fract, sorry. And so what we can do is look that up. I sure wish this was more searchable. One of the things that's challenging about working with OpenGL is the documentation is not super great. For someone who doesn't know what they're looking for, this isn't very helpful. But let's look at fract OpenGL and see what they have to say about that. And again, so we get compute the fractional part of the argument. Not super helpful, but we can go to the book of the shaders and look at fract, and we can see compute the fractional part of an argument. And now they have a little bit more, but not a lot more. What fract basically does is it returns what's left over from a vector or a float. So it's a little bit like a modulo. And we can use it like this. We can say, let's say vec2, and I'm going to just make another copy of this variable, because sometimes we get complaints if we try to modify a varying directly. So I'll say, I'm going to make a new vec2 called pos, and I'm going to set it to UV. And then I'm going to say pos equals fract of pause. And in here, we'll say pause instead of UV. And I think it will be oh, there we go. So now we've got this. We're dividing essentially the screen into to 4 areas. Let's see if we can make this be 4 circles by making a value. We'll make a value called center and make it equal to a vector 0.5. And now what I'm going to do is move the center, move the position over using the center value. And you can see we slid it over, and so now we've got these nice subdivided screen. And what's more? What else can we do? Oh yeah, we can make this be lots and lots of circles if we want to. We can say something like pause times equals 10.0, and then we get lots of circles. And so I'll totally grant you this, wrapping your head around how this code is working and why, and writing this code on a per pixel basis like this is a bit of a challenge. And the best I can say is you gotta just do a bit of it for it to start to make sense. But you know, I'm happy to eventually I'll make some more videos, and my videos will be better. I'm gonna probably go back and redo this and all the other videos before I actually release this course. Thank you all for being guinea pigs. Let me know if this makes sense or if it doesn't make sense. And in the next video, what I want to do is run ahead a little bit and use a noise function. And then we'll return to REGL, and we'll learn how to set these values dynamically. All right.